Good afternoon to all. I have switched off the camera because I am not sure about our internet connectivity because the last days it was a bit problematic, and I hope that it will work until I finish my talk. So, as Sarah mentioned, today I'm going to talk about actually geodetic ice. When I'm saying this, I mean what we were having, I mean, before 20 years and how geodesy helped us uh, in detecting and registering all these things. For some reason, the slide was not moving now. Okay. So, I mean, this work, I mean, is including a number of co-authors, as you can see here below in this screen. And they were affiliated, or they are affiliated from about 13 institutions worldwide. So it is a work which is generally uh, between many researchers. So do you see my slides properly?
Actually gone white. Oh, there you are. Okay. Mine was white. So
Okay.
you can see it?
So excellent. So I'm going to start from, I mean, most of you are, you know, all this image and things which I'm going to present here, but generally, I will start from this common background, why we have the divergent boundary in the East African region, and not only that, the Red Sea Rift and the Gulf of Aden Rift is due to, I mean, though it is still, some people are not yet still convinced, but there is this mantle plume theory, which is, as you can see, these nodes. It starts from South Africa toward Eurasia region. And at this point, as you can see from the area of South Africa, the mantle plume rise diagonally and hit between the third and fourth node. That means between this area, the Ethiopian highland, in the formation of the Ethiopian highland, the formation of the different rifts and so on, is mainly because of this mantle plume. This is more and more convincing now. And if you see earthquakes in the region since 1960, you can see that the number of earthquakes, and they are mostly following the three rift system, that is the East African rift system. Here you have the Gulf of Aden rift system, and this one is the Red Sea rift system. And if we focus now within the Ethiopian geographic boundary, if you see the frequency of earthquakes, you can see that this is some sort of episodic, and it is concentrated in few years. As you can see, the number of earthquakes normally is not more than 10 to 20 per year. But when I'm talking about this earthquake, these earthquakes are earthquakes above 3. And what we are registering in Ethiopia, we register a lot of more earthquakes, or we register more earthquakes, but this is what I have downloaded from the USGS homepage. And as you can see here, there are two major peaks. One is around 2005, and the other one is between 2023 and 24. If we see what happened, the geographic distribution, the 2005 event is around the Bahudaure area, and the 2024 and 25, most of them are around the Fentali Dauphin area. And the others this is around Asbe area, and this is around the famous volcanic lake around Ertale area. So in general, most of the earthquakes which we saw in the last 60 years are concentrated in this specific area. Of course, there are some earthquakes around the western rift margin. If you see also the magnitude and time distribution, you can notice that the amount of earthquakes which we are registering is we are going to the low magnitude earthquakes and this is obvious because in the early time we didn't have enough earthquake monitoring seismographs distributed worldwide. But as our monitoring facilities are getting better and better, you will see that we are also now registering small earthquakes. I mean, within Ethiopia, in the last 70 years, our network didn't grow the way we expected it, but we have about now 10 stations that are monitoring earthquakes. If we focus in and see the number of earthquakes that occurred during 2005, this is from the work of Manhalo, because there were a lot of seismometers that were installed in this area. You can see that actually the number of earthquakes are huge if we are counting the small earthquakes also. And this was due to this Dyke event that took place in 2005. You can see that from one minute to the next, the earth has opened about 500 meter in length and about 70 meter in width and about 150 meter in depth and so on. And there was ash that was thrown out. But in reality, I mean, the length of the Dyking event was about 60 kilometer. Now, when we see the geodetic, especially the GNSS monitoring stations, which we had in the last 25 years, you can see that there were about 52 stations that were distributed at different places, and most of them were through project, except some of them that were installed by Addis Ababa University. And of course, the Space Science and Geospatial Institute of Ethiopia. And as you can see, most of the stations are marked with X. These are stations that are not currently working, but the others are were working at least in the past few years. And this is, I mean, there were many publications when it comes to the velocity field of
Is it just me or did we lose Elias?
No, I can.
You Sue also, Sarah also.
Yeah, I don't hear him.
Okay, let's give him a few minutes.
I've lost as well.
Okay. I'm sure he'll be let me try phone him just in case he doesn't realize and he's busy talking to himself. I've done that before.
No, do you have WhatsApp? You could just WhatsApp him maybe.
I'm just looking where I put my phone. He's not very good at picking up WhatsApps, but when I phoned him earlier, now I've lost my phone. Okay, let me phone him my iPad. Okay, give me all 1 second.
Elias, are you back?
I am back. I'm sorry. As I've told you, our internet connectivity the last days is a bit
No worries.
sluggish. I'm sorry for that.
We're glad you're back.
Okay, great. Can you see me now? Do you see the
Not the screen.
slides?
No.
Yeah, you'll have to reshare.
Okay, I have to share it again. Okay.
And we lost you on the slide with the Berhanu 2015 velocity solution. Yeah, this one.
Yeah.
And then just remember at the top, in the middle, just click on display settings and swap it. So yeah. If it happens again, you could always email me the presentation. I can try and run it. There we are. Perfect. Wonderful.
Okay.
Let's try.
Okay, thank you. So now, as you can see, the velocity field, when we are fixing the Nubian plate, even within the Nubian plate, stations around the rift system are moving, but when we are going far away, for example, to the region like Asosa or Sarb or this area or Bahardar, the velocity is getting very low. Or in the bark also, you can see here, the velocity gets very less. So mostly this confirm, I mean, this goes very well with the earthquake distribution. So, I mean, when it comes to the stations, geodetic stations, as you can see, some of them are constructed in, I mean, properly, the way it is demanded by IGS, and some of the stations are on buildings and so on. This is also to give you some view about the Moho in the region. To the topography, the Moho also properly reacted. We have the deepest Moho depths in this region and but when we come to Afar, in the rift system, you can see that the Moho is shallower. When we go to southern region, not as shallow as we expect stage of the different rift system. And this is also shown here, directions. When you see here in the southern region, so the topography, in the topography, you show that there are rift system, but the Moho boundary didn't react. But as we go toward the central main Ethiopian rift, you can see that here the lower, the Moho depths is reacting. And as you go here to the northern part, I mean this profile, you can see that it is properly showing. But when you go across Red Sea, you can show that the lower crust mantle boundary is properly bulging. And when we go to the Gulf of Aden region, it is thinning to 3-4 kilometers only, the crust thickness. And this is also agreeing very well with data. This is from data, but this is agreeing with seismological data in G cubed. And there were also works, for example, to study gravity survey, which I took on this profile, this straight profile, which is about 162 far region. The Moho is getting shallower to 24 kilometers, but that's not the only thing. You can see big volume of melt within the crust, and even oceanic crust is being formed in the central part because the density of this material is above 3, which is almost in the region between the lower crust mantle density. This is not common for the upper crust region. And this is confirmed also through MT surveys, MT work. Now, I'll concentrate, this talk in what has happened mainly in this region in 2024-25, especially starting from September 2024 to February, March 2025. The region which I'm going to talk about is Fentanyl region. As you can see here, we have Fentanyl Mountain here, and there is a lake here south of it. We call it Koka Lake. What is interesting about this lake is this lake was not there before 50 years. It is slowly growing in the road, as you can see here, it used to be here, it was diverted, then it is being diverted. The lake is pushing the road more and more to the Fentali mountain. It is growing. We call it the growing lake. People are studying this. I mean, researchers from different countries are coming and studying it. Yet no one knows why this lake is growing. Anyhow, there is another lake, man-made lake, this one, because there is the Kasam Dam here, mainly for irrigation purpose. As you can see here, there is a sugar plantation in this area. But when you go northeast further, we have the Dauphin Mountain here, or let's not call it mountain, it's a volcanic center. This is the Fentali Volcanic Center. Here we have the Dauphin Volcanic Center. So here we have Fentali Volcano. Here we have Dauphin Volcano. There is Metahara town in this region. About 20,000 people are living here. There is a Sabure, mainly people working in the sugar factory. There is a Melkasadi here. Amibara with 10,000 people. Melkasadi is about 14,000 people. Awash, 13,000 people. Awash Sabah, 38,000 people. So why I am talking about the number of people, the risk in this area was also very crazy. There are about more than 100,000 people living in this region. So Lake people living in this area, the main road from Djibouti to Addis Ababa, as you can see it here, is passing through this region. And as you know, Ethiopia is currently a landlocked country, and the main route to the sea is through this road. And we have also our rail track, which is going in this area. So if something happened to this area, if there is volcanic eruption, then the whole nation will be in very serious trouble. And not only that, Addis Ababa is about 140 kilometers west of this area. If you take 20 kilometers or 125 kilometers away from this central area, and there are towns like Ankober and so very near. We have also the nearest Genesis station we had was in Ankober, about 52 kilometers away from. So on October 5, 2024, everything, as you can see here, was quiet except small earthquakes coming here. And in October 6, 2024, about 8 o'clock local time in the evening, that is -3 GMT, the whole Addis Ababa, people who are living in Addis Ababa felt the earthquake. And I mean, in the near past, people never heard earthquake in Addis Ababa, and the whole city, I mean, even though statistics say that there are about 5 million people in Addis Ababa, the unofficial estimate is 7 to 8 million people are living in Addis Ababa. And it is the seat of Africa Union. There are many international organizations like Economic Commission for Africa and so on. So there are, that is one of the largest diplomatic hub in Addis Ababa. So the whole city was in turmoil. And I was called to our university, and the whole night we were locating and working in this what caused the earthquake, and we should go to the media and calm people. As you can see, the next days, I mean, in collaboration with our collaborators in UK, Bristol University and Leeds University, we process the INSAR data, and automatically we knew that there was some sort of dike injection between Fentali volcano and the Sabure village, south of the Dauphin volcano. And for some time there was quiet period. In December 90, as you can see here, about the evening time, small earthquakes started to happen. And as you can see here, on the 20th of December, swarms of earthquakes. This was registered in our station at Addis Ababa University, and you can see the number of earthquakes that took place. And on the 29th of December, if you see the broadband station in Addis Ababa, you can see that even it was hard to identify which earthquake is following which earthquake, because we were registering more than 300, 400 earthquakes per day. And what was really frustrating was the whole dwellers of Addis Ababa were worried. There were telephone calls and so on. We were overwhelmed. The government was asking for advice. And
Elias, it is breaking up. I don't know if you can hear me. And it's at the point where everyone wants to hear what you're saying because it's so crazy with the events. Maybe we'll just give them a few minutes. I hope it's not.
insert data in the stations that was working.
There we lost him. Sorry all for the technical difficulties, the joys of across Africa communication, but I think you can agree such an interesting talk. So please do stick around if you can. Otherwise, yeah, I will stick around if you can, if you don't have any other commitments. Otherwise, I'll try put the recording up on YouTube by the end and we can see if we can take out the bits where we've lost Elias. But otherwise, please check your emails while we wait for him to return.
It
there,
is
Elias.
back again.
That's
It is
fine.
back again.
You showed us all those exciting earthquakes and then it started to break up, and I think we all wanted to hear what you were saying. I'm not sure
So
Sarah knows the exact title of the site, but it was, I noticed it, I think, when you showed all those, the multiple earthquakes. Yeah, that. If you go back one, what is the previous slide? Yeah,
this one was the
yeah, it
previous
started
slide.
to break up here, I think, from what I remember.
Yeah, I'm sorry.
No,
So
no.
you can yeah.
Do you want to just change the display settings in the middle, at the top middle? Perfect. I thoroughly enjoyed your talk in January, so it's worth hearing it again, even if there are breaks. So thank you for keep on going for us.
Okay, sorry for that. I mean,
no stress.
We don't know why. I mean, the last days we had this problem. So anyhow, you can see here the broadband seismometer, what we have registered. It was really hard to differentiate. I mean, one earthquake from the other, when one is started and when the other one was following. And our seismology group were overwhelmed by location, I mean, to locate earthquakes and so on. But as you can see here, at last, we plotted the distribution of earthquake from October to March 2025, October 2024 to March 2025. And this is, we later, as I will show you with the INSAR, we later saw that there were there was a diking intrusion that went from Fentale through to Dofan, about 50 kilometers long, and some old faults and new faults were old faults were activated and no new faults were forming. There were also some marginal grabens that were activated, as you can see in this area, in the northeastern area, and there were some other faults that were. So automatically, I mean, we noticed that this is some sort of dike intrusion, and we have alarmed that there might be some fissure eruption in the area. And the Disaster Risk Management Institute of Ethiopia automatically started to evacuate people. They have evacuated about 80,000 people in 2 months' time. And because INSAR image also properly gave us, as you can see here from the INSAR image, you can see the marginal gravels in this area, and you can see, you can count the number of fringe. There was more than 1 meter, about 1 meter 20 centimeter deformation in the area. And we had to prepare, this was especially, we had to do it urgently. We have been asked to prepare some sort of volcanic hazard map. So because we were expecting fissural eruption, we marked this one, red one, as a very an area which needed very urgent attention, because we cannot tell the government to evacuate. They should know. We told them, but this is an area which needed urgent eruption. Why we pulled it towards this direction is because we were fearing, though Fantalia was deflating. I mean, here you can see that in the INSAR image, Fantalia was deflating and this part was inflating, but we fear that it might flip and Fantalia might come aggressively and might block also this road. And even they had started thinking of constructing another temporal detouring road in the southern part of the lake. And there was a lot of preparation. And this area, which was marked yellow, was a no-fly zone, which is about totally not more than 30 kilometers in diameter. Why we did this was because we were there on the ground, we were monitoring closely from satellites and so on. We said, if there is an eruption, we will enlarge this area to 100-kilometer radius because it will give us time. But Ethiopian Airlines and other airlines took more caution, and they were away, as I had been informed, more than 50 kilometers away from this area. And you can see how INSAR data helped us in properly tracking. I mean, from the first day on, we were following as the Dyke was progressing northward. And this is the cumulative, the last one, but we were following, I mean, every 6 to 12 days as the satellite is coming, we are updating and following the case. So geodesy helped us a lot. Not only that, as you can see, I mean, this is a summarized version of the data, the yellow ones, the red ones, and so on. As you can see from this scale earthquakes, the blue ones here, what we are seeing is the location of Addis station. And as you can see, from September to October, it started to move faster, then it decayed. And at the beginning of December, where we have large number of earthquakes, then Addis moved also about 2 centimeters, as you can see, westward. It is interesting. This station is located 140 kilometers away from Addis, but it has sensed the movement, far field effect, and it has moved 20 centimeters. You can imagine the amount of energy that was released from this diking event. And as you can see here, we were seeing periodic eruption in this region at the beginning, and some termite nests. This one it is. Some termite nests were cracking in the area on the surface. In the phreatic eruption one, this one was this one, and automatically in 25 around, or 2024 in December. This is the sugar factory. It will stand a lot of earthquakes up to this time. But here, when this big earthquake took place, it was about 5.8. No, it was 6. The sugar factory started to collapse, and it was just below the sugar factory. The epicenter was at the sugar factory, but thanks to God, by this time, people were completely evacuated, and there was no any casualty And here, geodesy and geophysics played very big role to save life. Then the second phreatic eruption, I will show you a video at the end, took place at this time. And as you can see here, asphalt roads were cracked and they were deformed. And you can see that there is about 1 meter, 20 centimeter down throw of this area relative to this one. You can see this tree was tilted, everything was tilted in this region. And around Fantale, about January 23, 24, there was a very big landslide. One side of Fantale was moved down due to landslide because of continuous earthquake and so on. But later, after this one, I will talk about this one very short because I'm running out of time the way I see it. There were more earthquakes in the northwestern part of Ethiopia, started around this margin, around Adigrat area. You can see the distribution of earthquakes here in this area. It was very near to Mekelle, and this has also caused a lot of panic to people that are dwelling in Mekelle. Later, we have observed that there was also some sort of deformation in this area, but unlike the Fantale one, many houses in towns, as you can see here, their walls were cracked. Thanks to God, the main structures were not deformed, but there were also some old cultural cottages and so on were damaged, and there was one casualty. And because the earthquake was very big, you can see here a damage also to a structure of a building. Later, it continued, and as you can see here, this is Ertale volcano. South of Ertale volcano, in July 2025, there was a diking event. This is Ertale, and here we have Haile Gubi. In the Haile Gubi mountain, there was a volcanic eruption. And as you heard, even many airlines like Indian Airways and so on were stopping flying toward the Saudi Arabian region and so on. This is because, as you can see, the ash which was thrown from this volcano was moving in the east direction, and it was covering a large area, and airlines like Emirates and so on was stopping flight for some time. So in general, the activities observed in the last 2-3 years were really strong, and they were recorded in the 3 rift system. The cumulative seismic moment in the region indicates that the event was a significant seismotectonic activity. It has caused even the westward motion of Addis Ababa, which is located about 140 kilometers west of this region. And the total number of earthquakes registered from September 27 to March 17 was over 1,000. Even if we take the 4 magnitude or above from geophone, we have registered over thousands of earthquakes. The area was densely populated. That was our fear. Though 80,000 people, including farmers, were evacuated from the central diking area, but towns very near, people didn't want to leave their house, and we were really frustrated on what was going to happen, especially if there was a volcanic eruption. Now the question is, when is the next episode going to happen? Even last week, there was a 4.7 earthquake between Fantale and Dauphin. Fantale mountain is showing a continuous uplift in the last 2 years also, and the uplift is getting faster and faster, and we are closely observing from INSAR, using INSAR and seismic observation. The next question which we are asking is, because Fentale is now inflating, will there be central volcanic eruption at Fentale? This is the next thing which we are asking. And based on scientific evidence, what should we tell to government and decision makers? Because this is very important. This is really challenging for us, especially because of financial shortage and so on. We cannot purchase image, INSAR image and so on, high resolution INSAR image. But thanks to our colleagues in Leeds, Bristol, and West London University, they are continuously processing the data and informing us. And we are continuously processing GNSS data from wherever it is available. And then, the other question is, because now the earthquakes that are starting the last days are also along the Dyke, we are still asking, is the whole Dyke region active, or is it Fentale mountain area which is active? So here I will show you, thank you, and in the background you can see the because these are local people, it was recorded there. And this is a phreatic eruption in January 4, 2025. So thank you.
Thank you very much, Elias. Sorry, I've got my daughter here coughing. Thank you from everyone in the audience. Thanks for persisting with your internet. Are there any questions from the audience? I see a hand up from Sarah.
Yes, that was fascinating, Elias. I know I saw this in January, but it was easier to focus this time over on Zoom. I was wondering if anyone has connected if the Dyke intrusion, if the stress changes from the Dyke intrusion have triggered the eruption, the subsequent eruption that happened. Has anybody done that stress modeling that you're aware of?
Should I answer that, or should I wait for other questions?
Yeah, I think let's answer as people raise their questions. Did you hear me, Elias?
Yeah, should I answer? Okay.
Yes, please.
Sarah, I know that there are different groups in UK that are trying to work on that based on INSAR data, because as you know, we were not able to install GNSS instruments. We had instruments, but left from some projects, but due to the security situation in the region, which was not really good for us to go there, we were not able to install GPS instruments. There were many publications that are coming out. There are still some on the process, but I know that there are groups that are working in that, but yet not published.
Okay, great. Sorry, just to follow up, do you know if they found the connection? Do you happen to know, were they able to demonstrate, or at least suggest with the modeling, that the Dyke intrusion did trigger the volcanic eruption?
What is so far found is below the Fentale. Fentale was continuously inflating between 2015 and 2023.
Okay.
And suddenly it started to deflate. We started to see the diking. That means magma was coming out. What we believe so far is magma is coming out from Fentale and moving in the northeast direction, opening the whole ground. And it was a combination. The earthquakes were then caused because of two things. One is as the magma is cracking the ground, trying to find its path northeast direction. It was trying to come to the surface. When it was not able, it was cracking and moving to the northeast direction. And at the same time, old faults, I mean, due to the divergent, what do you call it, stress, old faults were triggered. And especially these big earthquakes were caused on movement on faults rather than due to the diking itself. But the diking has triggered these fault movements. But this has to be modeled properly. So far, they are working. I know that there are two publications that will come soon in the last part of revision update, and there are more works that are under publication.
That's exciting. Thank you so much.
Thank you, Sarah.
Thanks. Asenath, I see your hand is up. It's nice to see you online.
Hello. Thank you for the talk. I really agree with Sarah. It's been very informative. My question is coming from the key questions you were suggesting. Have you looked at previous history of the volcanoes, kind of like to project the recurrences that will happen maybe in the future?
Yes, there are groups that are working. I mean, the last information I had was, I mean, this volcano was active before 200 years or so, and there were studies that were going on because we were following this mountain for some times. As I said, in 2015, there were two publications, one from Professor Atala Ayele, and the other one is from Dr. Tesfaye Temteme in West London University also. And before that also, there were some work, I mean, that were studying the eruption history of the volcano. But as we have about 80 volcanoes, most of our volcanoes are not well studied. So we have to do, I mean, the international community should come together and we have to study these volcanoes together. And fortunately or unfortunately, I don't know, most of our major towns are very near to the rift system because of resources and so on. And we have to be serious about this.
Thank you.
Cool. If there are any other questions, please put them in the chat or just raise your hand. Can I just say before we start losing people, I was just going to share. I'm just looking that I'm sharing the right screen. I should have done this in the beginning, but I got very caught up with starting the talk. So we've mentioned, a few people have mentioned this talk was shared in January. We had an AfricaArray event at WITS, and there will be another talk. It was another AfricaArray event you can see on the screen in January 2027. So if anybody is interested in it, it is tectonic. It's relatively academic, but we also love to involve industry. There is a LinkedIn QR code on the screen, so please do scan it and join the LinkedIn page, and then you can just keep up to date about information about the event. So I just wanted to say that before people do log off. And then for any industry people here and academics, for both of them, there is the SAGA conference, which is the Southern African Geophysical Association conference, this coming October. Abstracts, you can see this is on auto play. Abstracts are due end of May, so please do get your abstracts in for that. But let me stop. Well, Elias, I had a question about the INSAR. Which group, or is it at your university that the INSAR is being processed?
Leeds, Bristol, and West London universities.
Oh, okay.
I mean, you know Juliet Biggs?
I don't, but I'll investigate.
Juliet Biggs is from Bristol University.
Okay.
Tim Wright is from Leeds University.
Oh, yes, Tim, I do know.
Yeah, and my previous student, Tesfaye Temteme, he is a lecturer now in West London University. They are processing the data. It's not only one person or two person. Juliet has more than 10 PhD students that are working on this area. And Tim has also few students that are working in this area. And we are trying also to do some work, but our server failed,
Okay.
which we purchased through one project, and we are more focused on the GNSS and other seismological. I mean, Professor Atale and his group are working on the seismology, and I'm working on the GNSS. And if situation security was good, we would have been happy also to carry out some time variable gravity survey, but the situation on the ground doesn't allow us.
Sure. That can't be an easy work environment for multiple reasons.
Yeah, I mean, that is, I mean, the worst thing of, I mean, this terrestrial geodetic survey. For seismology, you can monitor from very far away. Addis Ababa and all stations in big towns are monitoring the earthquakes. It's only INSAR that we are using, and of course, optical satellite image we are also getting from different universities. And resources are, I mean, a serious financial resources, serious problem. We need some projects to handle such kind of things.
I think the first time I met Tim Rice was in Iceland, and he presented on work they did in the far region, and they went in on camels. So it must be an interesting region to have to do groundwork. Let me stop the screen here so I can see if there's any other hands or questions in the chat. I can't see anything. Please do raise your hands, but otherwise, maybe we can, people are welcome to leave if they need to or stick online if you have more questions. Elias, thank you so much for your time and effort. We look forward to the next installation of the talk in January 2027. And just to say, my third year students were meant to join the talk, but I had to come home. So they will be watching it tomorrow with snacks and cool drinks at the university. So if they have any extra questions, we'll have to email them to you to get feedback. But thanks again for everybody who joined. Really, as Sarah was saying, like AfricaArray is meant to connect people and join a network of people. And we're so far apart from each other that we're grateful for things like Zoom and Teams, where we can at least see each other's faces more than once a year. So thanks for everyone joining in, and hopefully the network can grow. And have a wonderful afternoon and a wonderful day, Sarah.
Thank you, I mean, for inviting me, and I'm happy to see many people, I mean, following.
I know.
And that was very nice. Thank you, Stephanie. Thanks.
Well done. And
yeah,
I will post it on the YouTube channel, hopefully soon.
Thank you.
I can see Sue, I think we can see the side of your computer. I don't know if that was.
I'm just saying hello.
Oh, okay.
Hello, Sue. Hi, how are you?
I finally got my computer running again, so I'm so happy.
Oh, wonderful, Sue.
Yes.
I'm glad.
Yeah.
Okay. Well, okay.
Thank you, Stephanie.
There, now we can see you.
Bye. Yeah.
Nice.
I switched it off, I mean, just to save, I mean, the internet band.
Well, now that you finished your talk, now it's fine, and now it's letting us put all of our videos on. But anyway, okay, well, goodbye, everyone. Go have a good day, and thanks again for connecting.
Thank you. Goodbye.
Cheers. Bye.
Bye.